Hey, Chem 30. Today we're going to talk about esters, which is the next type of organic compound we're going to discuss. Esters are kind of this neat class of compounds because they actually have these really nice smells. They are used for artificial flavorings, for example. So it's kind of neat. In your workbook, you're going to see a bunch of different ester structures, and then it will even tell you what the flavor it is or what flavor it is based on that structure. Not that you could tell from the structure, but just it kind of says like, hey, this is banana flavoring, which is neat to see. Normally, if you were in school, we would actually do a lab for this where we would build esters. We would make esters through what's called an esterification reaction. You're going to learn about those next day, but we can't do that. But just imagine that they smell delicious. So an organic compound that contains the ester functional group, it is similar to that of an acid, a carboxylic acid, except the hydrogen of the hydroxyl group in the carboxyl group has been replaced by a hydrocarbon branch. It is represented by the general formula shown below. So often what we do is we actually show that we have a hydrocarbon chain with an R. I don't know why R is used, but that's what we use. And then we have another hydrocarbon chain over here. We'll call that R prime. But essentially just when I have my ester, I have two kind of carbon chains that are connected by this ester functional group that's right here, which has that carbonyl, the C double bond O, and then the carbon attached to an O, which attaches to another carbon. Now, when we name esters, it's really important to understand that there are two different hydrocarbon chains and to distinguish between them. This hydrocarbon chain that has the carbonyl as part of it is the carboxylic acid part of the ester, okay? Well, this part right here originally comes from an alcohol, and we'll talk about that in esterification as we learn how this works, but just important to realize that this is the carboxylic acid portion of the ester, okay, where I have the carbonyl group right here, and then the one that's just single bonded to an O, that is the alcohol portion of the ester. So getting into how to name this, we start with the alcohol portion of the ester, and we number the longest chain for the alcohol. And again, we have to make sure that the first carbon is attached to where the ester functional group is. So the first carbon will automatically be the one that's single bonded to that O. I then name branch positions, branch size, and chain, and alkyl groups, and whatever. I do the normal thing that I do. Now with the acid part of the ester, number the longest chain so that the first carbon is always connected to the carboxylic acid group. Name branch position and size of the branch is the same as in alkanes and organic halides. And then name the parent chain with the suffix O8. Now the alcohol portion of the ester actually kind of sounds like a branch. Okay, and then after that, I do a space. There's another place where I have a space. And then I go into the carboxylic acid portion of the ester, and it ends with O8. So you're going to see how this works out. Because again, we learn from the examples here, right? I mean, that's primarily where our learning comes from. So if I take a look at this structure from your workbook, I have this right here being the alcohol portion of the ester. And I say that because it's the one that's single bonded to the O. And then this right here is the carboxylic acid portion of the ester, where I've got 1, 2, 3, 4 carbons. And yes, I do count this as a carbon. So given that I have 1, 2, 3 here, I have propyl. So that's how I name it. I name it kind of like a branch. But the reason why it's not a branch is then I actually have a space, and then I do butane O8. So butane O8. Butane, because I have 1, 2, 3, 4 carbons that are a part of this, the carboxylic acid portion, and then the O8 ending is showing that this is an ester, functional group compound. Okay, why don't you try out B? It's similar. It's a really simple, nice little one. And for here, I've got an alcohol portion that's just 1 carbon. So this is a methyl. Then I'm going to leave a space. And then I'm going to go ahead with the 3 carbons here as a part of the carboxylic acid portion. Again, I know that it's part of the carboxylic acid portion because it has that carbonyl group right there, the C double bond O. So this is methyl propane O8. Methyl propanoate. All right, now we actually have branches coming off of stuff. So here I have a branch that is coming off of the alcohol portion of my ester. So this would be an ethyl, 1, 2 for the alcohol portion, but then I have a methyl coming off of it. Now, I could specify that it's 1 methyl, and that's fine if you do, but that's the only place that I could put a methyl on this, because if it was at the end, it would now be a propyl. But that's fine. We're still going to just specify, but you could leave that number off because there is only one spot it could go. So we would call this 1-methyl ethyl. Okay, so 1-methyl, that's the branch. Ethyl, that's the alcohol portion of the ester. Now I leave my space and I have 1, 2, 3 carbons for the carboxylic acid portion. So that's propanoate. So 1-methyl ethyl space propanoate is the name for that one. Now here I've got some branches coming off of the carboxylic acid portion. So again, a little bit different. So the alcohol portion for this is really easy. I've got 3 carbons that are coming off of that single bond O, the alcohol portion. So that's just propyl. Now I leave a space. And now I've got 1, 2, 3, 4 carbons in my parent chain for the carboxyl, and I have 2 methyl groups coming off of carbon number 3. So after my space, propyl, I would say 3, 3 dimethyl butanoate. 3, 3 dimethyl butanoate. Okay, so that's it. That's really esters. The big thing is that you have that O8 at the end to show it's an ester, and then we have the alcohol portion first, named kind of like a branch. Then we have an actual space in the name, and then we have the carboxylic acid parent chain name with an O8 ending. And then any branches you just kind of throw in there before the part that we're dealing with, the alcohol part of the carboxylic acid part. Now, when I say alcohol part, carboxylic acid part, it's no longer an alcohol, it's no longer a carboxylic acid, but that's where it came from originally, as you're going to learn about in the esterification reaction lesson. So I make esters by reacting an alcohol and a carboxylic acid and then bringing them together. So you're going to learn about that, and that's why we call it the alcohol portion and the carboxylic acid portion, because it is referring to the reaction that makes it. But we're going to leave that for another day. All right, have a good rest of your day. Goodbye.